Hello everyone, welcome back again to Bio Tutorials. So we've done with our previous lessons with the basic concept and definition of thermodynamics, and we're done with also with the pure substance, and now we're going to proceed in chapter 3, which is the ideal gas. So ideal gas, also called perfect gas, a gas that conforms in physical behavior to a particular idealized relation between pressure, volume, and temperature, or called the ideal or general gas law. In simple terms, a perfect gas is a gas that follows all the gas laws from the Charles law, Avogadro's law, and all the laws about gas. So according to this figure or this image, according to the ideal gas law, when a gas is compressed, pushed down into a smaller volume, the number and velocity of molecular collisions increased, raising the gas's temperature and pressure. So if it expands, the velocity of molecular collisions decrease, lowering the gas's temperature and pressure in the other way around. So for better understanding, let's proceed on solving some problems about ideal gas. Example number 1. A balloon is filled with 30 liters of helium gas at 313 Kelvin and 153 kilopascal. What would be the volume? So here we're going to find the volume B at 273 Kelvin and 101.3 kilopascal. So the volume that we're going to determine here is the final volume. So first we have to write all the given values that we have from this problem. We have the initial pressure, which is 153 kilopascal, and our initial volume, which is 30 liter, and our initial temperature which is 313 Kelvin, and our final pressure which is 101.3 kilopascal, and the volume is unknown, and our final temperature is 273 Kelvin. So in doing so, we have to follow this equation in order to solve this problem. We have P1 multiplied V1 over T1 is equal to P2 V2 over T2. And by plugging all these values into this equation, we have 153 kilopascal multiplied by our initial volume, which is 30 liter, over 313 Kelvin, is equal to P2, which is our final pressure is 101.3 kilopascal multiplied by our final volume over 273 Kelvin. So we do the math or the calculator tricks by using shift solve. We can directly get 39.5 liter as our final volume.